We are going to take a look at the internal structure of a WebWork problem file. So these problem files are the ones that I have a collection of, and I will pass them along as needed. Here is an example of a directory for Calc 3 where I have a whole bunch of problem files that I've already built. And so we are going to open up a couple of these that I've also renamed as examples of different features, because we have to be able to ask questions that require numerical input. We have to ask multiple choice. Those come in the form of what are called radio buttons, little circles that students can click in to activate an answer. In Math 260, we have to be able to ask them to input full matrices, and so there's different structures to the input. So what I have here at first is just an example of a problem that involves kind of generic numerical input as well as a multiple choice button. So there are different zones to the problem file. The comments you can see are the double hashtags, what we used to call pound signs. So the top section is just informational, although the top 3 items help archive the problems in the WebWork problem directory so that if people want to search by a particular subject, that these problems can be found. So I'll tell you about that in a minute. And then there's an initialization section. This is kind of like LaTeX, where there's the base package, and then to do other things you have to add in special additional sets or files. The writing of this code is a hybrid of Perl and some language that the people that wrote WebWork decided to sort of assemble for themselves, I think. And then we can also embed LaTeX. There's a section for problem setup where you define things like variables and answers and get things set up. And then there's the main part of the problem where you set up how the display is going to work. This is where LaTeX will come in, and most of the LaTeX commands that you're used to will be identical. It's just a question of going in and out of the LaTeX. And oh look, I see a goof here. In this particular problem, is the triangle defined by those 3 points in an isosceles triangle? So I need the students to practice with the distance formula. Inline LaTeX in this environment is kicked off and closed out by a backslash parentheses. So this $sign is a leftover from when I copied and pasted and changed all my $signs to slash parentheses, and I missed one. Farther down after the problem statement is the answer checking, which hopefully doesn't have errors, where the information collected by the answer boxes or the radio button selections on the part of the student is then compared with the final answers. And at the very bottom is a solution, which as instructors in WebWork we can see at any time, but students can only see it once the deadline for submission has expired. Now, just because these sections in the document appear in this order, that's not necessarily the order in which you want to lay them to work on them in. So actually the first problem or the first area to focus on is going to be the problem display. So this might be where you take a look at a problem statement that's written in the book and originally intended just for somebody to write a solution. And you have to think about how to extract from them information about their solution, which can be communicated by numerical values, multiple choice. They can enter expressions of, with variables and have them checked, and that's fine. But, they're not just writing everything down on paper and then scanning the paper for you. You've got to draw out the good information that they've come to. And so this is where you want to start. And you can copy in, say go to a LaTeX file and copy in the actual question and maybe change it up a little bit to focus it better on what you're going to ask, but it should still be essentially the same question. So if they've done the work in advance, when they come here with their solution in front of them, they'll know it's the problem that they worked on, and then they're just going to have to, extract from their own work the information that you're asking for. When they get to WebWork, this shouldn't be the first time they're encountering these problems, at least in this context. So this is where you might want to start. And so you're putting in the problem statement, and you've decided by the time you get here, well, how am I going to ask for the information? Am I going to ask for them to give me a numerical value? Am I going to ask for them to answer a multiple choice or a true false? Or am I going to ask them to type in for me some sort of expression? Once you get all that thought out and arranged, then you can head back up to this zone in the problem setup where you actually define all of your answers. So you don't really have the answers to define until you've already decided how you're going to present the question, and you might as well just go ahead and build the question in as your first goal. And then after you build in the question, you can go down here and build in the statement of the solution, and then go back up and do the details. So here are the details. Again, you'd come back up here and create your answers themselves, or any expressions that you might want to display multiple times. You can define them in advance instead of having to LaTeX them out all the time. And then up at the top, after you've thought through the problem, you can think of the keywords that you might want to associate the problem. And then also the subject, chapter, and section part up here is very specific. And I'll show you in a second the list of the architecture that we want to pick these headings from. Okay, so the overall bird's eye view is bring in the problem, whether it's just by copying and pasting LaTeX or whatever. It should be fairly identical to what's already been posed to them in the notes, but you can massage it a little bit based on how you're going to ask for the information. And there's plenty of examples for you to look at already with what I've done. So you've decided what kind of answers you're going to get. So you need to learn how to format your answers. Now you're going to be hopping back and forth between LaTeX. Right here is what would be a LaTeX statement, except the dollar signs are replaced by the slash parentheses. If I had a bigger expression, say right here, this wasn't just a point, but maybe I wanted a large quotient right there, I could actually set up the parentheses and then use the / display style command like in LaTeX to make it appear a little bit bigger instead of inline. The inline LaTeX is set off by the / parentheses. You can also have a / with a hard square bracket, and that will just be LaTeX set off as its own line and not inline. In a place where you are going to ask for a numerical value or some sort of functional expression to be put in, you include this answer rule, and this will create a box. The bigger the number that's inside the parentheses, the bigger the box will be. 15, I think, is supposed to measure how many character widths wide the box is. I mean, if I type answer rule 3, I happen to know that's probably a good size if you're going to ask somebody to enter an integer. 15 is big enough that if they're going to have to write out something with x's and y's in it, then they're going to have room for that. You just kind of get some intuition. And then here is where I lay out some multiple choice options. Now again, the radio option, the $ radio 1 is the name of the collection of responses that's defined above. We'll get there in a sec, but this is where it's deployed right here. So which of the following is true about this triangle? And then here's this statement of deployment of the radio buttons themselves, and then it's getting sent into the button format, the button environment where the answer is collected for handing off. The big thing about this is, just like with LaTeX, with HTML, the best thing to do is just look at other problems that have something similar to what you want to do and steal it. Or go, do a Google search for WebWork and function entry or something like that, and you'll get to their wiki pages where there's descriptions and examples and things like that. So it's impossible to give an overview up front. It's just knowing what the options are. You'll have parallels that you can draw from and hopefully get things set up. So in this particular problem, we're asking for 3 numerical options. We're asking 2 multiple choice questions. One's deployed here and one's deployed down here. I can see that there's so here's a good example of just troubleshooting. So $radio 1 is the name of a radio button environment that's been pre-selected above where you can see, but this is a mistake right here. So this is probably an older version of this problem that I didn't quite fix. I probably copied it into place with the intent of updating more. Is the triangle defined by the points given an isosceles triangle? There should be a radio button option here that just says yes or no and let the students pick between those. Down here at the end, there's a statement, which of the following is true about this triangle? And then there's another radio button. It probably, if there were two different multiple choices, we'd have like radio 1 and radio 2, and one would have the yes no answers laid out, and then the radio 2 would have the statements to select from. So now I'm going to scroll up and see what the heck is going on. So now I'm up here. I am in the problem setup. You're going to notice in the problem setup area, this is where you're defining all your variables. Variables are indicated by $signs at the beginning. There's different contexts. So there's the numeric context, which is kind of your baseline. That's where you're going to operate unless otherwise you need to switch it. So here I'm defining answer values, like the square root of 45 would have been the distance between a couple of points. The square root of 36 is the distance between other points. So I'm setting those up here as the correct answers. And then here's my radio button set up. This variable radio 1 is created as a radio button array, and then different statements. It is isosceles because the length of one side is greater than the other two. It is isosceles because no two lengths of the sides are equal. That's false as well. So there's a bunch of options in here, and right now, it looks like number 1 would be the true statement. It is not isosceles because no two lengths of the sides are equal. That would be the good one. Now, in this radio buttons environment, you see parentheses, brackets, and then the brackets are closing out over here. What happens is you can list out the first 4 statements that are going to be the choices and the multiple choice, and then you close out the brackets to say, hey, my list of options is done, and then there's a comma, and then the correct response is repeated. So it's options, comma, correct answer. And that's how it matches. Now, I really wish these could be numbered. So the correct answer, I could just say, hey, it's option number 2. But for whatever reason, you actually have to duplicate what the statement is. Hey, I didn't write WebWork. Let me show you a different context, which you have to worry about linear algebra, but not in calculus. Well, actually in calc later on, if you have vectors and you want to display them as like a single column matrix, you might need to know about this. So here's another problem where it's going to present several answer boxes for just numbers, but also some matrices are being created, either just to display or because we're going to collect answers as matrices. So in the numeric context, we're just lining up answers that are answer M2, N2, et cetera, and then here are some matrices, and I'm showing you this so you can see the context of matrices is turned on while these are being defined, and you can see the structure of a matrix environment. So here's a $, ants for answer, ANS, A1, being defined as a matrix, parentheses, and then this is like you might type a matrix into, say, Wolfram Alpha or something like that, where the matrix is surrounded by square brackets, and then within the matrix, each individual row is surrounded by square brackets. So this line right here is a 3 by 3 matrix where the first row is -2, 1, -3, and so on. And so there's a bunch of matrices being built. And then those matrices are either displayed down here, or those are waiting in the wings as answers. And down here in the actual problem statement, for example, this is a weird statement, and you get to learn it as you've used it and copied it and pasted it from other places more. But here, this is the matrix answer A1 is being directed into an array environment. So what's happening here is that this answer array environment looks at answer A1, finds out what size it is, and then builds an answer array of boxes of the same size so that students can actually answer by filling in the individual entries of the matrix in the like 3x3 array of little mini boxes. And then once the students fill in that array, their input is stored for the answer checking farther below. All right, so problem statement with all of the input zones. Here's answer rule 3. That's just a very small numerical entry box. Here's a given matrix being deployed to the answer array checker so that WebWork knows how big of an array of boxes for answers to display to be filled in, and a lot of those are collected. All of those are defined up here, the answers and the things for display. And then finally down here, we have the answer checker where you just have to keep track of in what order did the answers come in and have them all checked. So right here, the information collected from the student in the array built for answer A1 is put into the comparison checker. So student values compared to the correct values. And then the numerical values are checked. And then the last question up here is another matrix array that's being filled in, and that's the last thing that gets checked. And then the students will submit their answers, they'll get a score, and then after the deadline they can come pop open the solution and see what's going on. Up in the initialization, just leave whatever is there. You can probably guess that if you took out parser radio buttons.pl that the radio button options wouldn't work. These are like style files in LaTeX. So just as you copy problem to problem, just leave this section alone unless something ends up not working and you do some Googling and find out that you need another macro loaded. And then go find it and load it. All right, finally up here at the top, this stuff is fairly self-explanatory. In Math 260, the title of the text is the same, the edition is the same, the author is the same, and then you'll know what section and what problem that you are building, so you can edit those two spots. And then in same thing in Calc 3, the title will be, let's see if I can find it. Yeah, casual calculus. You can change the section, change the problem number as goes on. The subject, chapter, and section. Now, one of the things I'm going to hand you is basically a little directory that goes along with WebWork. And in this directory, you can see the subject, chapter, and section architecture of the entire library. So this is the one that would go with multivariable calculus. So the database chapter is calculus-multivariable. That's the not indented level of this index. And then there we see calculus multivariable as the subject, the overall subject. I misspoke when I said chapter. The chapter is the next level down. And you can track that just by following the indentation. So the big subject is multivariable calculus. And then what we're doing right now might be differentiation of multivariable functions, which is the chapter. And then within that heading, maybe we're doing partial derivatives. And so those three items become the subject, multivariable calculus, the chapter, differentiation of multivariable functions, and the section, partial derivatives. And again, that's so that in WebWork, these can be dialed up by people searching for subjects at different levels, as opposed to just going through a list of problems in numerical order. If we take a example from linear algebra, from Math 260, here's linear algebra is the global category for that subject, and then different chapters, quote unquote, down below. Like Math 260 is never going to do inner products or anything serious with linear transformations. We'll be doing some spans and linear combinations and linear independence at some point. But right now, it's matrices. So let me go pick up a 264 type of problem, 260 type of problem, where the question here is going back and forth between here's a system of linear equations, what does its augmented coefficient matrix look like, or vice versa. And so up here you can see that this particular problem would go in the linear algebra subject. Everything in 260 is going to come out of linear algebra just about. We happen to be dealing with systems of linear equations and then augmented matrices, and you can find those over here. So we're in the linear algebra hierarchy, so we actually aren't using matrices where we're using them, but we're not in this subject heading. We are more specifically down here in systems of linear equations, and then students are being asked about augmented matrices that are associated with those. So yeah, just follow the indentation, 3 levels: the big subject, the kind of chapter heading, and then what might be a section heading in the book. Those are how you tag the subject, chapter, and section at the tagging and description level of this. All right, so that's a ton of stuff. And so you're getting delivered these sample files that you can keep off to the side. Say, hey, I want to do something with radio buttons. Let's go with that example that has a radio button in it, instead of having to hunt through all the previous problems and figure out which one might happen to have a radio button. So you're going to get that. You're going to get all the problems I've built for Math 253 and Math 260 already that you can use as baselines. And then I'll give you a list of problems that you can try to create working examples with. And so you have this video that talks about the structure of the homework problems themselves. There will be a video about file management on WebWork. Say you're working on your computer and you've taken an old problem file and you've renamed it and turned it into a new problem. How do you get it into WebWork in the first place? And then I'll make a third video about, given that you've uploaded one of these files, how do you go test it, check it, and maybe do some follow-up editing.